sorry I could not be here today. I have a daughter who is sick, so what I want you to do is please take out your 5A study guide. I'm going to go through the math problems because you still are going to have to take your quiz on the math problems the next time I see you, but we'll review those again before you take them. All right, if you look at number 7, we had a wavelength of 590 nanometers. Okay, so what they tell us, what the known, is that our wavelength is equal to 590 nanometers. The unknown here is the frequency. Okay, now again, hopefully this is just double checking. The equation that we're going to use is the speed of light is equal to the wavelength times the frequency. And in order to plug this in, we have to have nanometers be in meters. And so I'm going to do that up here. So if I have 590 nanometers, okay, in 1 meter, there are 10 to the 9th nanometers. This should have been the first thing that you did. And it should be 5.9 times 10 to the negative 7th meters. Okay, now the other thing that we always know, and you will get these numbers, is that the speed of light is 3.0 times 10 to the 8th meters per second. That's why we have to have this in meters. We set it equal to 5.9 times 10 to the negative 7th times the v, which is what we're looking for, and in order to solve for it, we divide both sides by 5.9 times 10 to the negative 7th. And our answer here should be 5.1 times 10 to the 14th. And for your unit, can you either have hertz, you can have seconds to the negative first, or you can have 1 over s. You don't need to put all three, you just got to pick one, but it does not matter which one you need. And if you need to replay this video, I'm going to put it in the resources section of eChalk. I'll put it in with our other lecture videos in case you need to review this, because I'm going to talk fast because I got to get out of here. All right, but anyway, then if you go down to the next one, number 8, this time we are given the frequency. I'm going to highlight this here. We're given the frequency of 9.55 times 10 to the 7 hertz. When radios broadcast, they broadcast in megahertz. Mega is not something I made you memorize. Mega is actually 1 million. So there'd be 1 million hertz in 1 megahertz. But I did the conversion. But we want to know the unknown is the wavelength. So we use the same equation here. We still know the speed of light, 3.0 times 10 to the 8th is equal to, this time we're looking for the wavelength, and we have the frequency, which is 9.55 times 10 to the 7th hertz, or 1 over s. Again, to manipulate it, we divide both sides by 9.55 times 10 to the negative 7th. So for our wavelength here, we should end up with 3.14 meters. Now just a note on significant figures, there's 3 sig figs in my answer because my data had 3 sig figs. We do not use the speed of light to limit our significant figures for these problems. Okay? All right, next math problem is you're going to need the frequency of a gamma ray that carries an energy value of 1.7 times 10 to the 11th joules. Now this takes us to the second equation that we have to be familiar with, and that is energy is equal to the Planck's constant times the frequency. It's the same frequency we had in the last equation, but we've got E equals hv. H is Planck's constant, which you will be given. Now they give us the energy. We're looking for the frequency, so we should have our known and our unknown over here with that information. The energy is 1.7 times 10 to the 11th joules. We know Planck's constant, 6.626 times 10 to the negative 34th joules times second, and we're looking for frequency. So in order to manipulate it, we're going to divide both sides by 6.6266 times 10 to the negative 34th. We should have got a frequency value of 2.6 times 10 to the 44th hertz for our answer. Okay? All right, then the other and we will take the time to go through the rest of these questions in 5A the next time that I see you, but I wanted you to at least have the math feedback so that you could do the rest of it, okay? The last math problems that you would have had to do, we had done 410 together. We did this in class together. You had to find for a wavelength of 434 nanometers, you had to find the frequency, and then you had to find the energy. And you do this in 2 steps. You do the frequency using the speed of light equation. And before you do that, you do have to go from meters to nanometers. Okay, and this would be 4.34 times 10 to the negative 7th meters. 3 significant figures in your data, so you're going to keep 3 significant figures for all of your answers. This becomes your wavelength. You know the speed of light, so 3.0 times 10 to the 8th is equal to 4.34 times 10 to the negative 7th. We're looking for frequency. Divide both sides by 4.34 times 10 to the negative 7th. Our frequency should have been 6.91 times 10 to the 14th hertz. Then we take that frequency and we plug it into E equals hv. Okay, so it's the same frequency. We're going to plug it in here just like we did with the first one. We're looking for energy, 6.626 times 10 to the negative 34th times 6.91 times 10 to the 14th. We simply multiply. Don't forget to use parentheses or you will not get the correct exponent. 4.58 times 10 to the negative 19th joules. Okay, at this point I'm now going to explain the electron orbital energy sequence, and it's not going to make total sense, but if you don't already have it, you may need to pause the video. And everyone should have a sheet that looks like this in front of them. Okay, so if you need to pause to get that passed out, go ahead, but everyone needs a sheet like this. Okay, I'm going to go ahead and keep going. First thing I want you to do is to put your name on this so that if someone gets it back to me, I can give it to you. Okay, luckily we don't have to label too many things. All right, this is a list of all of the orbitals that are available. Now, first of all, go ahead and cross off 8s. It potentially could be there, but we don't have it right now. Bohr, and just a little background, Bohr had 2D orbits. Well, let me slow down here. Orbits, which are those planetary orbits around the nucleus. The biggest update to the quantum model, and we will fill in our atom level, is that the quantum model said we have, and orbits are 2D. We now have 3D orbitals. Not sure why I'm on time delay. Which, if you look over by the respect bulletin board, there are 3 dumbbell shaped 3D orbitals, and this lists all of them in order. And in the first energy level there's only an s orbital, the p energy level there's 3, the d's there's 5. Now for homework you need to make sure that you watch the 4C video, but you need this information in order for it to make sense. So don't feel bad if you're still a little bit lost. I'm going to give you 2 ways to know the order that electron orbitals are filled. So on your sheet you need to draw some arrows. I'm going to draw an arrow through the 1s. Okay, so everyone go ahead, if you haven't done that, draw an arrow through the 1s. I do not want to see that message again. Then I'm going to draw an arrow through the 2s. Because here's the thing, it would be really great if these all went in order. We went from the first energy level, the second to the third. And what you're going to find is we start to overlap when we get into these d's and these f's. So draw another line through p and s. 2p and 3s, another line through 3p and 4s, and now you see we start to overlap. Another line from 3d to 4p through 5s, another line from 4d to 5p to 6s. Hopefully we see the pattern by now. Okay, and if we follow the arrows, it gives us the order of the orbitals. So somewhere on your sheet I want you to write this out. Write 1s, and all I'm doing is following the arrows. 1s, 2s, 2p, and 3s. So that's my next line. 3p and 4s. And then I go to the next line, I go from 3d to 4p to 5s. So 3d, 4p, 5s, 4d, 5p, 6s. Then we go back to 4f, 5d, 6p, and 7s. And then finally we have 5f, 6d, and 7p. Now what's going to happen is that in the next PowerPoint, you're going to learn how we fill these orbitals and how we draw electron maps. But we need to know the order. So this is one way. This is using what's called the diagonal chart. If you're someone who likes to take tests, write something down, scribble it, and you've got it, this is your thing. If this does not make sense, there is another way to remember this order, and you can do that by using the periodic table. Now we will, the next time I see you, take the time to write on a periodic table and label it. I'm not there today, but I'm going to show you the pattern. If you flip over onto the back of this sheet, oops, you have a sheet that looks like, let me get all this erased here. You have a sheet that looks like this. Dun, 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 dun. And you will see, I'm going to leave this here for a second, if you read the periodic table from left to right, you get the same order here. If you start at 1s, this is where hydrogen is. This is where helium is. Okay, then you go to 2s, which starts with lithium. Now there's 2 there, but then you go to 2p, which has boron. And this just follows the periodic table. You then go to 3s, which starts with sodium. You then go to 3p, which starts with aluminum, and then you start to overlap, but you can also use the periodic table. So again, this is the same order that we got from the diagonal. If you read it all the way from left to right, you know, when you get to down here, you go from, just to show you, you go 4s to 3d to 4p, 5s to 4d to 5p, and then this is where the f's would go in. And the periodic table we're going to have next week is going to be a big one. You'll probably see this from other Chem 1 students, but it puts the f's where they belong, and this is where the overlap really kicks in, because you go from 6s to 4f, back to 5d, etc., etc. The order does not change, and I promise after we get a chance to do some of these next week, it will make more sense. So don't panic, but you need to know this. And for homework, in a minute here, you're going to start to work on the 5B study guide. Okay, you need to watch the 5C video, or you're going to be really lost on Thursday if you have not done that. And we do have a math quiz, but you're going to see on your study guide that you do tonight, there are some problems that are similar to that. We will go over those, and I will answer any questions before you take the quiz. Be good for the sub. I'll see you guys on